So this is a quick video on initialising the cardiohelp, and we're going to go up to the point of dividing the lines and being ready to run on. In order to initialise the cardiohelp, you need to find yourself some space, potentially away from the patient and away from the scene, but within earshot. So we have our cardiohelp, we have our circuit, which in the real world will be slightly better packed than this one, which is a training circuit, and you're also going to need your stand. Okay, so you're going to come in, you're going to put the cardiohelp down, and the first thing you want to do is turn it on. Whilst you're waiting for it to boot up, I like to lift up the protection arm here and let it boot up. I'll bring the circuit into play, removing the body of the circuit. And the part that we're most interested in at this point is the oxygenator. I'll try and remove any kinks that are in the circuit. Look at the rear here. We're going to attach the oxygenator to this circle here. This is the part of the oxygenator that needs to attach. So I like to think the round circle to the roof and the pipes obviously going outwards. Line the circle up, the horizontal. Rotate it a little bit anti-clockwise until it clicks into place with this little tab here. Once it's clicked into place, I would then come back to the front of the machine. The first thing I want to do is disable some alarms. I hold down S and push the alarm button. A quick look at the battery, make sure we have enough battery, which we do. And then I'm going to have a quick look to make sure the SVO2 sensor has initialised successfully, as it tells me down there in the square. Often, if this sensor is not attached to the arm, that won't initialise successfully. Okay, so they're the 3 steps that I need to do at the front of the machine. Coming to the rear of the machine, I trace the circuit back to the priming bag. And then I want to hang the priming bag on the priming stand. The first 3 clips are very easy to put on. You can see there, 1, 2, 3, they're fixed. The 4th one has just got a little toggle to allow a bit more play, so we can pull it out and then tighten it right up. This is an important step. If you don't tighten this priming bag, it can actually, the negative pressure in the circuit later can cause it to cavitate. Alright, so that's up out the way, and all 4 of our clamps here should be closed. Okay, back at the cardiohelp end. 3 main steps. The venous sensor. The venous comes off the arm and down onto the circuit. Pressure probe. Pressure sensor off the machine onto the circuit. Flow probe needs to go on the arterial limb of the circuit. And you'll see there's an arrow that tells you the direction of flow. So the arterial circuit goes to the patient, so we attach that with the arrow pointing to where the patient would be. We've got our 3 sensors on. We need to attach the oxygen tubing from the cylinder to here to lower down the arms. The other thing I like to do at this point in time is grab our 2 clamps and just attach these to the tab on the side here. So they're available later when we need them. We know how to find them. Okay, you can see them on there. Right, now in order to get this machine spinning and primed, we need to turn up the revs to about 2000 revs. You see at this stage we don't have any flow. That's because the circuit is clamped. So we come round the arterial limb, 2 clamps need to be undone. The venous limb, 2 clamps also need to be undone. Sometimes, especially in these training circuits, there's a little bit of residual air that needs to be worked through. And in this case, you can actually hear the air going through the oxygenator. A lot of air going through the oxygenator. So what we'll do, the rear of the machine, the alley cap, we can remove to help with the removal of air from the circuit. And we just want to spin the machine at 2,000 to 3,000 revs until the air has worked its way through. If it's only small amounts of air and we're still establishing stable flows, this will work its way through until it's quiet. You can inspect all the ports and the pigtails off to the side. If you want to open up the taps, they're under pressure, so they will just bleed out if you want to get any air that you can see in there. Any tiny micro bubbles in the machine, we can give them a bit of a tap and a bit of a shake to help it work it through. Ultimately, you want to let this machine spin until it's quiet and until the flows are completely stable. So right now I can't hear anything, and we've got 4 litres of flow for our 2,500 revs. So I'm going to place the yellow cap back on. Now, I don't want to leave this machine unattended and spinning, so I'm going to take it down to 0 revs, 0 flow. I'm going to re-clamp. At this point we're going to put 6 clamps on. So that's 1, 2, 3, 4 of the originals. We're also going to clamp the circuit at the machine end. This is how we're going to manipulate the ECMO flows when we go onto flow. So 6 clamps in situ, sitting at 0 flows. We're attached to oxygen, but the oxygen is not flowing, and we're now just waiting for the team timeout. Presuming we have the team timeout and the decision is to go onto ECMO, and we're happy to commit the circuit, because remembering, once we disconnect this part of the circuit, we're opening it up to the environment. It's no longer sterile and it can't be used anymore. So this is a very committed phase. We will only be committing the circuit once we've had the team timeout and the dilation process has been started. To commit the circuit, we basically want to remove the priming bag aspect so we have a closed loop. So we're going to take both limbs. There's a disconnection piece here, and you can see clamp on either side. So using a no-touch procedure, we want to disconnect, and then we want to, preserving the water as best we can, reconnect that. That would actually be closed and sterile. So, place it on top here. Now, this is the point in time that we want to put the machine aside by the patient's left foot and move into position for handing up the lines once the doctors have confirmed that the cannulas are in.